Let's write some unit tests. Hello, Daniel here, and in this video we'll begin to explore how to write unit tests for a ViewModel class that uses LiveData and coroutines. You will learn how to set up your project with the necessary and a few handy dependencies, as well as how to best structure your tests for both efficiency and readability. Let's add a unit test to our important To-Dos app, starting with the TodosViewModel file. This file is responsible for the state and business logic of our To-Dos fragment file. In other words, the To-Dos fragment is constantly monitoring the changes in the TodosViewModel in order to know when it should perform some of its actions, such as display the list of to-do items or navigate to the details fragment when the user taps on one of the items in the list. In our TodosViewModel, we can see that it has three methods that we can test, and that we are getting the list of to-do items using the DAO.getAll function and storing that list inside of the to-dos property. Additionally, we have a new to-do title property that just gets initialized with an empty string. As a reminder, we update the value of this property directly from the fragment to-dos XML layout file using DataBinding whenever a user creates a new to-do item. To write our first unit test, we'll need some additional tools. Let's open our app's build.gradle file and add the following dependencies. JUnit4 should already be included in the project, so we'll just make sure that it's there. Truth. This is an assertion library which will make our tests more readable. MockK is a mocking library for Kotlin. We'll need to create a mock version of our DAO object to give to the TodosViewModel to make sure that we only focus on testing the functionality of the TodosViewModel and not the DAO. ArchCore has a few helper functions to test things like LiveData, which we're using in the properties of our TodosViewModel. Also, don't forget to sync your project's Gradle file afterwards. Now we can open up our TodosViewModel file and right-click anywhere in the editor, or use the keyboard shortcut Ctrl-N and select Generate and then Test. In the pop-up that opens, make sure JUnit4 is selected and click OK. Then in the destination screen, make sure that the test is being added to the unit test directory and not the Android test one, and click OK. Android Studio will generate the test file and place it in the correct directory for you. Now we can begin writing our test by first declaring an instant task executor rule at the top of the file. When we test functions that deal with LiveData, which is a way to manage and observe data changes in Android apps, these operations can take some time to finish, since they happen asynchronously. The instant task executor rule ensures that when we run our tests, the tasks related to LiveData happen immediately and in order. This way, our tests get the data they need exactly when they expect it. For the next step, remember that we're only testing the TodosViewModel functionality right now. But when the ViewModel class is created, it needs a DAO object, and it makes a call to the DAO.getAll method. We need to create a fake or mock instances of these and a real version of our ViewModel to test it. Let's create three variables as follows. First, we're going to need a mocked version of our DAO to pass to our TodosViewModel. So we'll create a latent var, we'll call it testDAO, and we'll annotate it with @MockK. We'll be able to use this to initialize our ViewModel for testing. Then we'll also create a latent var called TodosViewModel of type TodosViewModel, and this is going to be the real instance of the ViewModel that we're going to use for testing. Lastly, we'll create a mutable LiveData list, which we'll use to mock the call to DAO.getAll that happens at the top of the ViewModel. Now we can create a setup function that will 1. Initialize our mock test DAO using the MockK annotations.init function. 2. Declare to our program that the DAO.getAll function needs to always return an empty LiveData list in our tests. And 3. It will create an instance of our TodosViewModel using the mocked DAO we created earlier. We'll also annotate this setup function with @before to make sure that it gets called before each of the tests so that it can perform these setup steps before each test. Now we're ready to write our first test, and so we'll use the @test annotation and write a new function below it. Since this is a unit test, Kotlin allows us to write the name of the function either using camel case, which is the usual way we write function names, or as a full sentence using backticks around it. This is pretty handy because it makes our tests more readable. For this first test, we're going to check that the onToDoItem method from the ViewModel changes the value of the navigate to to-do property to the value of the to-do ID we give it. We can write our test using the given when then pattern, which helps to improve our test's readability and structure. This means that our test basically reads like a paragraph in English. Given we have a to-do ID of 1, when we call the onToDoItem method with that ID value, then we assert that the value of the navigate to to-do is equal to the ID we provided. There you have it, our first unit test. Well done. Using the same structure, we can now add another test for the onToDoItem navigated method to make sure that the navigate to to-do property's value gets reset back to null. This test will read as, given the onToDoItem method is called with a value of 1, when onToDoItem navigated is called, then we assert that the value of navigate to to-do is null. That's 2 tests down. Well done. Now let's add a test for one of the most important parts of the TodosViewModel, which is adding to-do items to the database. This uses the addToDo function from the ViewModel, which needs to execute the insert function from the todos DAO file. And because the operations from the database need to happen asynchronously, we run this code inside of a coroutine. And so, to test the addToDo method, we need to add the Coroutines Test library to the dependencies in our build.gradle file. This gives us some handy utilities for testing coroutines, such as the run test function. Now, one of the main goals when writing tests is that they should be deterministic, which means that if we give them the same initial conditions, the results of the test should be the same. However, since coroutines run asynchronously, the time that they take to execute can vary. To make this duration more consistent for testing, we can use something called a test dispatcher. So, back in our test file, we can create a new variable and use the function standard test dispatcher that we got from our Coroutines Test library to create a new test dispatcher. Then, inside of our setup function, we can set the dispatcher for our tests using dispatchers.setMain. And we also want to add a teardown method and annotate it with @after so that it runs after all tests in our file. Inside this function, we can reset the dispatcher back to the original main dispatcher using dispatchers.resetMain. Now we can write our tests. Here, we want to validate that the DAO.insert function gets called only once. This is going to make sure that our addToDo method is working as expected. So our tests is going to first declare what our expected behavior is. We're going to use this coEvery function from our MockK library to declare that every time we call DAO.insert and we pass it any type of object, this method just runs. Then we're going to create a new title for our to-do object using a random string value such as make testing YouTube videos. And we're going to assign it to the new to-do title property in the TodosViewModel. We then launch a coroutine scope and then call the addToDo method from the ViewModel. This should create a new to-do object with the title that we just provided. We then need to call the advance until idle function to make sure that the operation of adding the to-do to the database completes before we do the verification. Now we can write our assertion using coverify, which is also from the MockK library and is used for testing coroutines. This allows us to assert that the DAO.insert gets called exactly one time when we call the addToDo method. And finally, we can click the play button at the top of our class to run all of our tests. Hopefully this was a brief but helpful introduction into unit testing on Android. I highly recommend using libraries such as MockK for mocking, truth for assertions, and the given when then pattern to make test writing easier and improve the readability and structure of your tests. Stay tuned for my next video where we'll discuss testing the data access object and the interactions with our room database. Thank you so much for watching. Take care.